This is CPM Calculus Chapter 3, number 34. So in many textbooks, or many other textbooks, the derivative, or IROC, instantaneous rate of change, is described in terms of x and delta x instead of x and h. So for us, we know that given our function f of x, we defined our derivative is f prime of x is our slope function. We know it's going to be the limit as h goes to 0 of f of x plus h minus f of x divided by x plus h minus x, right? So this is our derivative using h and x. So other books, instead of saying h, they say, well, what if you just have delta x there? So instead of saying, well, here is our curve, right? Instead of adding, this is x, instead of adding h here, right? You add h to get here. Well, let's just add delta x. Okay, so they use some delta. And then they'll define the slope function to be the limit as not h, but as delta x goes to 0. And instead of f of x plus h, f of x plus delta x minus f of x divided by x plus delta x minus x. Okay, so when you simplify this, you still get the same thing because these two cancel out and these two cancel out, right? These two cancel out and these two cancel out. So you still get f of x plus h minus f of x over h, and this one's f of x plus delta x minus f of x over delta x. So both h, so why, explain, no, so let's look at the question. Explain why h and delta x are equivalent. Both h and delta x, well, what are they? They're just describing a difference starting at x and you add a little bit, right? Both h and delta x describe a small difference. They're just using different variables, right? Semicolon. Just using different variables. The meaning of h and delta x would be the same. Okay, so these two are equivalent. Okay, so let's go on to part B. Part B says to use the picture and the definition of the derivative to write the slope of the tangent line in terms of x and delta x. Okay, so here we have a picture. Here's x here and x plus delta x. So we're adding, right? This difference here is just adding a delta x to x to get to this point. Okay, and right here we see we're using 2 points. So this line is called the secant, and we want to find this line is the tangent. Okay, so the tangent is the slope exactly at the point x. The secant, remember, uses 2 points and creates a line using those 2 points. So our definition of the derivative, we know that f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by x plus h minus x, right? The change in the y divided by the change in the x, and taking the limit as h goes to 0. Well, now if we want to write this in terms of the tangent line, well, we still want, what do we want to approach 0? Well, we want this difference, right? If this difference is approaching 0, we're getting closer and closer and closer as this delta approaches 0, we're getting closer to this 1 point. So our difference is becoming closer and closer and closer and closer until we can create the tangent line based off 1 point instead of 2 different points. Okay, so now we want the limit And basically we're going to substitute in for h, we want the limit is delta x goes to 0. Okay, so this difference is just our h before. And instead of the function at f of x plus h, we want the function at x plus delta x. And we still want to subtract the function at x. And now we want to divide it by x plus delta x minus x, right? And we know that x plus delta x minus x, well, the x and the minus x cancel out, so that's equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x, okay? So as this difference right here, delta x becomes smaller and smaller and smaller, then we're shoving this point to the left, right? It's approaching x, right? So as the difference gets smaller, approaches 0, we're making these 2 points into 1 point and we get our tangent line, okay? Or you could say it's the slope of the tangent line in terms of x and delta x. All right, so here is the equation. And this ends CPM Calculus Chapter 3, number 34.